All right, let's talk about bone development. Osteogenesis. Osteogenesis meaning bone growth, bone formation. So most bones are formed using what is the process called ossification. Ossification means bone formation. So what you're going to do is you're going to mineralize over hyaline cartilage. So you have cartilage first, and then you cover it with hard bone tissue. And that happens when you have cartilage, and then you get some osteoblasts that come in, and they're going to secrete that bone matrix, which is the calcium phosphate salts. Now, how does that happen? You have interstitial growth. Interstitial, like interstitial fluid, also meaning, so this is going to be between the bones, between parts of the bones. So long bones, that would be arms and legs, increase in length. They only grow, they only get longer at the epiphyseal plate. Epiphyseal, E-P-I-P-H-Y-S-E-A-L, epiphyseal plate. So how does that happen, and why do we have hyaline cartilage? The way that this happens is you first have an increase or growth. So you have growth of hyaline cartilage. Growth of hyaline cartilage. Then you get the bone matrix that's secreted. We call that calcification, adding calcium. And that's going to turn it into bone. Now, so that's how bones get longer. You also have a way for bones to get thicker. That is called appositional or apositional. It starts with an A, not an O. APP, appositional growth. And what it does is osteoblasts, those are going to be our bone builders. Osteoblasts, they're going to form new osteons. That would be functional bone units beneath, so new bone units underneath the periosteum. That would be that outside covering of the bone. So right underneath, we're going to get this new layer of functional bone units. So osteoblasts are doing that. Then at the same time, you have osteoclasts. These are our bone crumblers, and they are going to enlarge that middle medullary cavity. So it's happening on two ends. This is how bones get thicker. So they can grow where we put in cartilage and then cover it with calcium and make it bone, or we can get thicker where your osteoblasts are laying down new bone underneath the periosteum, while at the same time the osteoclasts are enlarging the cavity so that there can be more osteons, room for more osteons. Stick with me, not too much longer. Bone homeostasis, remodeling and repair. So at any point in an adult human, bones are being formed, so bone tissue being deposited and being reabsorbed. So they're being formed, they're being broken down continuously in order for repair to strength in areas that have stress. How does it happen? First thing, bone depositing. That happens when you have an osteoid seam that first appears. This is cartilage. The seam comes up, the seam is first cartilage, and then it's going to become bone. So you've got unmineralized, so you've got your cartilage, you've got your matrix, and then your osteoblasts come in and they lay down the calcium salts to make it hard. So this is bone building by osteoblasts. Bone resorption comes from osteoclasts. These are our bone crumblers. And they have these enzymes that come from osteoclasts, and they actually digest the organic bone matrix. And then they turn the calcium into a calcium ion that can enter the blood. So this is a way to get calcium into the blood. That's going to be important in AMP2, getting calcium in and out of bone. But that happens with osteoclasts. So you can think about osteoclasts, get calcium. Crumble bone, get calcium. Good way to remember it. Okay, so that's remodeling. You can also do this in response to mechanical stress or to gravity. This is known as something that is called Wolff, W-L-O-F-F. So probably a German guy, be my guess. That's what happens when a bone grows or it remodels in response to stress that's on it. So it makes it stronger where you need it. So bones get stronger when you need them. So this is one of the reasons that they tell particularly women to reduce the risk of osteoporosis, to do weight-bearing exercise. But in particular in weightlifters and bodybuilders, they're going to have their bones are going to be thickened right where they're connected to a lot of muscle tissue. So because there's a lot of force and a lot of stress that's put on the bones there, so it needs to be reinforced, it needs to be built up. In space, astronauts aren't subject to gravity. So there's not stress that's being put on the bone. So because they don't need bone, the body says, oh, well, you don't really need it. Let's use our cells and our metabolism for other things. So that's actually one of the major time limiters for how often astronauts can do spacewalks or stay in space. It's related to their bone atrophy. And right now it's basically irreversible up to a certain point. So that's an area of big scientific research in area. So if you want to go work for NASA, you can. Now, when you have compressed areas, they tend to become negatively charged. Maybe that's a stimulus. We don't really know exactly what triggers the body to do this, but it does. So you put pressure, you put stress on an area of the bone repeatedly, the bone's going to respond by getting stronger in that area. All right, it's all on page 3. Let's turn the page. Let's see here. No, I'm not talking right now. Oh, here we go. This was the picture I was going to show you. Related to ossification. So this is what happens in utero. So you have a baby whose initial skeleton is made of cartilage. You can't even see that. There it is. So you have a baby, their bones are made of cartilage. And so that's how it's originally formed. Then they're going to start getting some hyaline cartilage. Is going to start their matrix is going to start breaking down. Then it's going to get some blood supply coming in, and it's going to start laying down some calcium. So you've got more blood vessels here at the top. You've got a bone shaft. There's the medullary cavity. As it gets bigger, there's more room to lay down bone. So this gets bigger. This is osteoclast, making this cavity bigger. This is osteoblast, laying down more bone matrix. So it's pretty cool how that process develops over time. And the process works the same way in an adult. All right, now we are on page 4. Not a lot of words on here. Moving on up. Y'all are doing great. Thank you for bearing with me. So, bone growth and bone remodeling is controlled by hormones. What the heck is a hormone? A hormone is a chemical messenger, or messengers if we're talking about hormones, and it is released from one organ and it has an effect on a different area. It may or may not be a different organ altogether, but it has an effect on the different area from where it is. So, ones that we care about. The anterior pituitary, that's up in the brain. You'll get to learn all about it in A&P2. It releases growth hormone. Growth hormone. And the thyroid hormone can actually help regulate growth hormone. Ooh, it gets really confusing in there. But also, the liver releases something called insulin-like, it's not actually insulin, insulin-like growth factor. So this process gets real complicated real quick. I'm going to try not to make it overly complicated. So, if somebody has hypersecretion, that means too much. If somebody has too much growth hormone, they have a condition which we call Giantism. These are the people that are very, very tall. It is a disorder. You'll talk about it more in A&P2. If you do not have enough growth hormone, that would be hyposecretion, so we can say not enough. In that case, you get something that is called pituitary, because growth hormone comes from the pituitary. But if you're not tall, if you're not a giant, again, these aren't politically correct, but it is called dwarfism. So you can be a giant or you can be a dwarf. Again, not politically correct, but it is what it is. All right, so that's how bones are told to grow or not grow, regulation of those. So you also have control of blood calcium levels. The bones are where the body stores calcium. So you can think of bones as calcium reserves or depositories if you prefer. Both of those are appropriate. So we're going to look here in page, let me find it, 7.14, page 233 is where I'm going to be, but not yet. So here's what happens. You have vitamin D gets changed to something called calcitriol. Here's the pathway. Vitamin D, this is one of the reasons we say we need sun. So sunshine. So when you have sunshine, which you can't see, sunshine, it's going to release UV rays. I know we say UV rays are bad. UV rays are bad. That's why we don't go to the tanning bed. However, some UV rays are good for sun exposure. Those react with the skin. Too much, you get a sunburn, but it's necessary. This is a normal pathway. So you have the skin. This also happens when you drink milk. So if you drink milk, you get, so either of these pathways, something called vitamin D3, which is different. All right, so we take vitamin D3 from the sun, from milk in the diet. All right, so vitamin D3 then goes to the liver. So here we are in the liver. In the liver is going to take our vitamin D3 and it's going to add a hydroxide group on it, which you probably don't care about, but the liver does something to it, and it is now called calcidiol. Don't worry about the name for vitamin D3, it doesn't matter. Now, calcidiol then goes to the kidney. So that's sort of what the kidney looks like, Pac-Man. The kidney takes the vitamin D3 plus OH, and it adds another OH on it, and then it is called calcitriol. You may have somebody that tries to call it calcitriol. That's not wrong, but calcitriol tends to be the more appropriate pronunciation. All right, calcitriol, that is the one that is active. So that is active vitamin D. Calcitriol and is active vitamin D. Its job. Why do we care about vitamin D? They say, oh, you have to have vitamin D to absorb calcium. That is true. So this active vitamin D then goes to the GI tract. And so you can now absorb calcium from your diet in the small intestine. So you cannot get calcium from your diet without vitamin D. So most of the calcium supplements we sell are calcium plus vitamin D. Or you need about 15 minutes of sun exposure a day. So what they notice is people that wear so much sunscreen and may or may not have milk, they tend to be at higher risk of osteoporosis. So I'm not telling you to not wear sunscreen. I'm not telling you to go to the tanning bed, but some sun and some UV rays are healthy in very much moderation. So here you go. Let's look at it. Page 233. Here's the sun. The sun has UV rays. They go to the skin and it makes vitamin D3. It's actually called cholecalciferol if you care, which you probably don't. I don't blame you. Or you can get it from milk. Either way, you end up with vitamin D3. Vitamin D3 goes to the liver. It sticks a hydroxide group on this. Now we call it calcidiol. Diol, 2 OH groups. Goes to the kidney. The kidney puts on another hydroxide group way up here, and now it is called calcitriol, 1, 2, 3 OH groups. Then it goes to the digestive tract, and you can then absorb calcium. So very cool how that works. All right, we didn't talk about rickets. Let's talk about rickets. All right, they're on page 234. That says 232, 234, because it's a new edition. You can talk about rickets. Rickets disease is vitamin D deficiency, particularly in childhood. So low blood calcium, these people, these children are very bow-legged. They can't form, they don't have enough vitamin D, so they can't form calcium, so their bones can't withstand their weight and gravity, so the bones bow and bend under pressure. So it's usually low blood calcium. And they get more and more bow-legged as they grow bigger and they get heavier. So rickets is very treatable. We don't see it a lot in the developed world, but you will see it if you tend to go on medical mission. You might see that. All right. So what can cause rickets? It can be insufficient vitamin D from the diet, so milk. So if somebody doesn't have enough milk, or not enough exposure to sunlight. Now, let's talk about blood calcium. So this is how we absorb calcium, using vitamin D. So now that we actually have calcium in the blood, how do we deal with it? These are negative feedback, meaning the more you get, it says stop producing. The first one, parathyroid hormone. Parathyroid hormone. Okay, so parathyroid hormone comes from the parathyroid glands. That's easy to remember. You'll like that in endocrine. All right, so what ends up happening is, in response to, you have a decreased level of blood calcium. So you don't have enough calcium in your blood. So when you don't have enough calcium, this is a down arrow, meaning for the result, that results in an increase of parathyroid hormone being released from the parathyroid glands. Get used to this notation here, these flow charts. They're all over AMP2. Now, parathyroid hormone goes to the skeleton system, and it does two things. It's going to do two things. It's going to first inhibit osteoblasts. So we don't want to build new bone at all. We don't want to build new bone. And then its second job is to activate or increase the activity of our osteoclasts. And those are the ones, they're going to break down the bone matrix. So break down the matrix, and that's going to release calcium into the blood. So the overall net result is an increase in blood calcium levels. And since this is a negative feedback mechanism, negative feedback loop, as blood calcium increases, parathyroid hormone decreases. So negative feedback is. Much more on that in AMP2. All right, now, so that's how we crumble bone and get more calcium. Well, what happens when we have a lot of calcium when we need to store it? That is done by a hormone called calcitonin. Calcitonin comes from the thyroid gland, so very basically the same area of the body. So calcitonin. Calcitonin gets activated when you have an increased level of blood calcium. So you don't want too much, you don't want too little. This is how they work together. So if you have an increase in blood calcium levels, that's going to cause an increase in calcitonin secretion. And that comes from the thyroid gland. And it is the opposite of parathyroid hormone. So it is going to inhibit osteoclasts, because we don't want to break down bone anymore. We already have enough calcium. We need to store it. So we want to store the calcium by activating osteoblasts. So osteoblasts, their job is going to be build or secrete matrix to store calcium. So we're taking calcium out of the blood, and we are storing it in the skeleton. So as a result, we have decreased blood calcium. These flow charts all over AMP2. Hang on to this packet. You'll appreciate it later. I enjoy the endocrine system, but it is very complicated. All right, guys, this is the last page. Y'all are doing awesome. Thank you for sticking with me.